All right, I'm going to go through a quick lesson here, just factoring complex trinomials. This is a worksheet I had pulled off of the CUDA software. So I want to go ahead and go through a bunch of these questions. We've got a ton here, just working on complex trinomials. And these are trinomials where that leading coefficient is greater than 1. So let's take a look here. I'm going to factor these using charting. So in this example here, we're going to go ahead and take our leading coefficient, which is 3, and I'm going to write the factors of 3 down. And their flips, I'll do the same thing with the constant term, -5. And then I'm taking a look at product of the diagonal terms that come out to be -2 here. So again, taking a look here, I'm comparing. I want to take the product of the diagonal terms here, so 3 and -5. If you take a look here, if I do choose the 3 and -5, again, taking the product there, that adds to be -2. So the first column actually worked for us right away. So these are the two columns I'm going to use. So my answer here becomes 3p minus 5 times p plus 1. And now this is factored. And again, how I'm doing this here is you take your product of your diagonal terms, you multiply those out, in which case I get 3 and -5. Add them up. If you get your b value, then you just kind of write this down here. All right, let's take a look at the next question here. I'm going to go ahead and write the factors of 2. That's going to give us 2 and 1 and 1 and 2. Likewise, do the factors of our -9 value here. So that's going to be -9 and 1, -1 and 9, and -3 and 3. And I want to do this in such a way that the product of the diagonal terms comes out to be a positive 3 here. Going through these combinations, you notice if I choose this one, for instance, I'm going to get 2 times 1 is 2. 1 times -9 is -9. And if you add those up together, you're going to get -7. And that is no good. We need to get a 3 here. So then you can progress on and move on this way. You'll quickly see this isn't going to work. You're going to get an 18 right away. Try this next one here. I get 6 minus 3. And that's going to work for us here. And if you take a look just to show you, multiplying these diagonal terms here, I have 3 times 2. Is 6, and these diagonal terms here is going to be 1 times -3 is -3. If I add these together, you get your positive 3 here. So that's the one that works there. So we're going to go ahead and highlight these. And now you read this from left to right. So this is going to be 2n minus 3 times n plus 3. And we get our answer for this one. Moving along here, same idea. Going to go ahead and write down the factors of 3 and the factors of 4 here. Now you'll make the quick observation here that if I'm going to be checking product of the diagonal terms here, no matter what combination I choose, right, and you can see this yourself, no matter what combination I'm choosing, the product of the diagonal terms will be positive and adding them will be positive. There's no way I'm going to get a minus sign here. So what you have to do is add minus signs to these values. Notice that still keeps the product positive. -4 and -1 is positive, -2 and -2 is positive. 4, positive 4 for both. So by doing that, now you're ensuring that the products will in fact be negative, and I can actually get that -8 here. Examining this up here, we will find the following combination works. You'll notice here I'll get a -6 and a -2, which sums to be -8. So this factors into n minus 2 times 3n minus 2. Continuing on here, we've got our 5 and 12 we need to make our factors of. So this will be 5 and 1, 1 and 5. And for 12 here, we've got 12 and 1. Then we're going to have 2 and 6. And then we're going to have 3 and 4. And that is it. I need to get a 19 out of this. So take a look at the product of these diagonal terms. You'll see right here by taking this combination here, I end up getting the 1 and the 4 gives me a 4 as its product. And the 5 and the 3 gives me a 15 at the product. And that'll sum to be 19 that we need. So the answer here is n plus 3 times 5n plus 4. All right, moving along here. We've got factors of 2 and the factors of 5. I need this to come out to be 11. We can see right away by taking these two columns here, we end up getting our product, adding up the product of the diagonal terms, we get 11 here. This ends up being 2v plus 1 times v plus 5. Moving along to 6 here, same idea. The factors of 2 and the flips. And then the factors of 2 are just 2 and 1. Take a look at here. I got to get a 5 out of this, and right away these two work. And you'll see this will factor into n plus 2 times 2n plus 1. All right, let's take a look at 7. For 7, same idea. So factors of 7 and the factors of 28. We do have a lot of them here. So kind of running through this here, got all of these ones here. And I need this to come out to be a 53. And you'll quickly notice here right away, taking these two columns here, we have 7 times 7 gives me my 49. And then 1 times 4 gives me my 4. If I add that together, I get 53, which is what we needed. So now the answer here, again, reading that left to right, is going to be 7a plus 4 times a plus 7. All right, let's take a look at number 8. So we've got here 9 and 1, 1 and 9, and 3 and 3. We've got all the factors in their flips. Do the same thing with 21. Again, I don't need the flips for 21 because if you do your kind of all the permutations here in the flips, you're set for this side here. Don't have to do that. I need this to come out to be 66, in which case if I take these two columns here, you'll notice I get 3 times 1 is 3, and 3 times 21 is going to give me 63. Add that together, you get your 66 that we need. So the answer for this is going to be 3k plus 21 times 3k plus 1. So you'll notice with this question here, something interesting happens. I end up finding one of the factors has a common factor inside of it. What that tells me is that the original question I could have factored before I went ahead and did my math on this, because this is not fully factored. If you notice here, I can GCF out a 3 out of this binomial, which is going to give me 3 times k plus 7 times 3k minus 1. And that is actually what we have here is your complete fully factored answer. So the mistake making, or what I wanted to show you, is that by doing so, it's not wrong when you do this, but if you do see a common factor like we have here, I could have done more initially. And what I mean by that is the initial question that we have here, I could have factored a 3 out of here, leaving me with 3k squared plus 22k plus 7, and then done my charting on the 3k squared plus 22k plus 7. If I would have done that here, I'll show you what we get. And you'll see here by doing this, we end up getting here, I can take a look at these two columns, and that'll give me the 22 that I need. So that means that this expression here by itself will factor into k plus 7 times 3k plus 1. So my final answer is 3 times k plus 7, 3k plus 1. And we got the same answer as we had previously. Let's take a look here. So moving on to 9 here, again, based on the lesson I had shown you from the previous question, you always want to look when you are factoring if there is a GCF that I can factor out of your trinomial ahead of time. And you'll see here with this one here, I can factor 3 out of here, leaving me with 5n squared minus 9n minus 2. And then we still have a complex trinomial inside that we want to factor, but it's a little bit easier. You can just do charting on smaller numbers, which is always an easier task. And by going ahead and doing that, I can see here that by taking this column with this one, I'll end up getting that negative 9 I need. So this is going to factor into 3 times n minus 2 times 5n plus 1. Take a look at 10 here. You'll notice right away I don't have a GCF I can factor out of this, so we're going to have to go right to charting. This factors as 5 and 1 and 1 and 5. And your 9 here, because of that minus 18, I need to have negative numbers incorporated in this, so I'm going to have to go ahead and add minus signs on these factors here. And I need this to come out to be a negative 18. And you'll see here right away by taking these two columns, I'll end up getting that because I'll have the 1 and the negative 3 is negative 3, and the 5 and the negative 15 is negative 15. That'll sum to be negative 18. So this factors into x minus 3 times 5x minus 3. And keep in mind, as you're working alongside myself with these questions, sometimes, depending on what order you put your factors and what order you decide to write them down, you might have, your answer might be read as 5x minus 3 times x minus 3. It does not matter. These would be equivalent. Multiplication is commutative operation. You can always flip these around, and they represent the same answer. Let's take a look at 11. So for 11 here, you'll notice right away I don't have a GCF. I can't factor out that 4 or any factor of that 4. So I'm going to go ahead and go right to charting on this. We get 4 and 1, 1 and 4, and the only other combination is 2 and 2. The same thing with 25 here. I end up getting 25 and 1, negative 1 and 25. Keep in mind that is a unique combination. these are not the same. 1 here, 25 is negative, and this combination 25 is positive, so it is unique. And I want to go ahead and get a negative 15 out of this. Taking a look here, I end up getting, by taking these two columns here, I get the 4 and the negative 5 is negative 20, and the 1 and the 5 is 5. I end up getting my negative 15 here, so this will factor into n minus 5 times 4n plus 5. All right, let's take a look at 12 here. So looking at 12, you'll notice, again, I don't have a GCF here, but I can go right to my charting, and I get 4 and 1, 1 and 4, and I'll use the 2 and the 2. Again, because of that minus sign here, I'm going to go ahead and do negative 7 and negative 7, negative 49 and negative 1. And taking a look here, you'll see I end up getting here the following two columns work. You'll see I end up taking the product here, I get negative 7, and the product here is negative 28. That'll add to be my negative 35 I'm looking for. So this will factor into x minus 7 times 4x minus 7. All right, let's continue on here. So for this one here, again, no GCF on this, so I go right to my charting, and I'm going to have 4 and 1, 1 and 4, 2 and 2. Likewise with this one here, because of that minus 17, I'm going to tack on negative 4 and negative 1, and negative 2 and negative 2. And I'm looking for the product to come out to be a negative 17, and you'll see right away these two columns do it for me. I end up getting n minus 4 times 4n minus 1. All right, take a look at number 14 here. So same idea here, no GCF on this, so go right to charting. We've got 6 and 1, 1 and 6, and then we have 3 and 2, 2 and 3, and again, I need to get a 49 out of this, negative 7 and 7, negative 49 and 1, and lastly, negative 1 and 49. So need the product of the diagonal terms to sum to be a 7 here. Taking a look at all combinations, you'll notice what works for us is the following combination here. I get 3 times 7 is 21, and then 2 times negative 7 is negative 14. That'll add to be 7 here. So this ends up factoring into 3x minus 7 times 2x plus 7. Moving on to 15. So for 15 here, same idea. We've got 6 and 1, 1 and 6, 3 and 2, 2 and 3. And same thing for this one here. I just don't need the other combinations. I need this to come out to be a 37, and you'll see by taking these two columns here, I end up getting x plus 6 times 6x plus 1. So right away for 15 here, you'll notice here I cannot factor out the 6 here, but what I can do, and something that is useful, is I can and should factor out the minus sign. So by factoring that minus sign out here, I end up getting here 6a squared plus 25a plus 25. So whenever you do have a leading coefficient that is negative, you should factor that out, else your final answer will not be fully factored. I'm going to go ahead and now do charting on the complex trinomial inside. So I end up getting 6 and 1, 1 and 6. And for 25 here, we've got 25 and 1 and 5 and 5. And I need this, the product of the diagonals come out to be 25, and you'll notice here we end up having to take these two columns here. That'll work for us. And my final answer is, don't forget to copy the minus sign down, so it's going to be minus 3a plus 5 times 2a plus 5. I can go ahead and do the factors of 6, which are 6 and 1, 1 and 6, and then 3 times 2. And likewise, the factors for negative 6 are negative 6 and 1, negative 1 and 6, and negative 3 and 2, and negative 2 and 3. And I need to choose these such that the product of the diagonals, when I sum them up, I end up getting a 5 here. And you'll notice by taking these two, that works for us. And my answer here is 3n minus 2 times 2n plus 3. All right, last question here. Take a look at number 18. You want to look for a GCF on this, and I have a GCF of a 4 out of this. So factoring out a 4, I end up getting here 4b squared plus 15b minus 25. And then we're left with a complex trinomial inside. Doing charting on this, I end up getting here our 4 and 1, 1 and 4, 2 and 2. And likewise here I get negative 25 and 1, negative 1 and 25, and negative 5 and 5. looking for a combination that works here. I got to get a 15 out of this, and the combination that does it for us here is going to be the first one with the last one here. I end up getting the 20 minus 15. That works. So the answer is 4 times 4b minus 5 times b plus 5. And we have our final answer. So here's just 18 questions going through examples of factoring using charting, complex trinomials. You'll notice some of these we have a GCF we have to apply first, but the principle is all the same. Thank you.